All right, in this video, I'm going to take a look at continuity. Okay, if you're taking a calculus course or you're going to prepare for the AP Calc exam, you're going to need to know this test or this definition. So a function is continuous if basically three things happen. One, you need that the function needs to be defined at a particular value, A. The limit has to exist at that value, and then they have to agree. The function and the limit has to agree. So I'm just going to give you a few examples of how this looks in terms of graphs. All right, so let's just first of all, the thing to note is this definition basically covers all the cases we care about, and that's why it's like a carefully chosen definition. And I'm going to give you sort of a sample of all the ways that things can be discontinuous rather. So for instance, here we've got a graph with a hole in it. And let's just note here, I'm just going to assume that's a 2, that's a 1, and that's a 2. Let's just test our definition here to see why this fails the continuity test at x equals 2. So first, we need to indicate whether f of 2 exists. So does f of 2 exist? It does. F of 2 is equal to 1. Now we need to check whether the limit as x goes to 2 exists. So let's see, the limit as x goes to 2 is equal to, well, we can see that from the left and the right, the graph is approaching 2. So there's your limit. Now the last thing we got to check is whether or not they agree. So is it true that the limit as x goes to 2 of f of x, is that equal to f of 2? And the answer is clearly no, right? 2 is not equal to 1. Okay, so therefore the function is not continuous at x equals 2, which you noted probably intuitively because in tracing that graph from left to right, you have to lift your finger to get all the values. Let's try it on this graph here. Let's say that's a 2, let's say that's a 1, let's say that's a 4. So we check what f of 2 is. So f of 2 is equal to 1. Let's take a look at the limit as x goes to 2 of f of x. Well, as you come from the left-hand side, the limit is equal to 1. As you come from the right-hand side, the limit is equal to 4. Since the right and the left-hand limits don't equal each other, that limit does not exist. Okay, so I'll just kind of put in parentheses here. The reason that doesn't exist is because the limit as x goes to 2 from the left does not equal the limit as x goes to 2 from the right. Okay, so that's another way. I mean, we can see there that's called a jump discontinuity. But again, using our definition here, we can see that it's catching all the ways that a function could be discontinuous at a point. And then lastly, we see here that the test fails immediately because if this is our function and we were interested in whether it was continuous at x equals 3, we can see that f of 3 does not even exist. There's a vertical asymptote there. So the function would not be continuous there. Okay, so that covers all the cases. As another exercise, what we can do is just take a look at this graph here and indicate from this chart basically how functions can be discontinuous at points. So what I'm going to do is I'm just going to note here from this graph that f of negative 3 is equal to 4. F of negative 1 is equal to negative 3. F of 2 does not exist. F of 4 does not exist because of the vertical asymptote. And f of 7 does exist, that's equal to negative 2. Now let's take a look at the limits. As x approaches negative 3, the limit from the left-hand side is equal to 1. The limit from the right-hand side is equal to 1. The limit, therefore, from both sides is 1. Is f continuous? Well, no, because for continuity, for it to be continuous, we want this to equal this. We want it to exist and those to be equal. So our answer is no. Okay, let's test at x equals negative 1. At negative 1, the limit from the left-hand side, I guess I got to go up a little bit, is 9, the limit from the right-hand side is equal to negative 3. Therefore, the limit doesn't exist because the left and the right-hand limits don't match. And so it's not continuous at x equals negative 1. Let's look at x equals 2. We noted the value doesn't exist at 2. The limit from the left is 3. The limit from the right is 3. Therefore, the limit from both sides is 3. And is it continuous at x equals 2? The answer is no, because the value doesn't exist. So it didn't have a shot to begin with. Let's keep going. At x equals 4, there's a vertical asymptote. As you come from the left-hand side, the limit is infinity. From the right-hand side, it's negative infinity. Therefore, the limit doesn't exist because those don't match. And of course, it's not continuous there. So then we arrive at our last situation. This is as x approaches 7. As x approaches 7, the value of the function is, as we saw, negative 2. The limit coming from the left-hand side, is negative 2, and from the right-hand side is negative 2. Therefore, the two-sided limit is negative 2. So that was the only place in the graph where our function was continuous. Okay, so this is a good overview of essentially all the situations that could arise involving continuity. So this was just basically a short introduction to the definition of continuity, the test you want to apply, especially if you're preparing for something like the AP exam. And in another video, I'll just give you an example of how to apply this test to a piecewise function.